Imagine an elephant, but with tusks at least twice the size of those borne by an elephant living today. Imagine an elephant, but covered in a thick, shaggy coat of hair, some of those hairs over 1 metre in length. Imagine an elephant which lived not in the warmth of the tropics, but in the ice and snow of the north. The woolly mammoth. These majestic titans ruled Europe and Asia long before our own ancestors fell under their spell. Extinct for thousands of years, they are iconic, yet mysterious. Climate change means that the frozen north is melting faster than ever before. Prehistoric carcasses are emerging, and from them we can unlock the secrets of these long-lost beasts. Using the latest technology, we can now answer questions about the mammoth, which have long puzzled scientists.
This is, in essence, virtual time travel.
That's starting to sound a little bit like Jurassic Park.
We're able to trace their evolution, revealing their adaptations to one of the harshest places on the planet.
This is amazing!
And with every new find, we take a step closer to answering the biggest question of all. Why did these magnificent animals suddenly go extinct?
I want to show you.
Oh, fantastic. Oh, that's brilliant.
I want to share with you.
Siberia. Here the temperature hovers around -40 for months on end. Few animals can survive here. 100,000 years ago, it was a different story. This giant swathe of Eurasia was home to vast herds of woolly mammoths. Perfectly adapted to the extremes of the Arctic, a tiny population survived on a remote island until about 4,000 years ago. But on mainland Siberia, they mysteriously died out at the end of the last ice age. But we're left with a treasure trove of their remains, locked in Siberia's layer of frozen ground. The permafrost. As global warming raises the Earth's temperature, melting the permafrost faster than ever, the secrets of the mammoth are finally emerging. After centuries of collecting their remains, we can paint a detailed picture of these long-lost beasts far better than we can for any other extinct species. We know that they lived for up to 60 years and were perfectly built for life in the freezer. But many of their adaptations have remained secret until now. And there's one big question which remains unanswered. What killed them off? This is one of the most famous mammoth finds of recent years. She's called Lyuba, and she's a little baby mammoth, probably just a month old. She was found in 2007, and she is amazingly well preserved, so that we have her skin, her soft tissues, and we even have the contents of her gut. Lyuba has been radiocarbon dated to 37,000 years old. Found in the far northwest of Siberia, she's considered to be the best preserved mammoth ever discovered. It's wonderful to get so close to this little baby mammoth and see how beautifully preserved she is. You can see the texture of the skin. You can see individual hair follicles there. And there's even some fur preserved, some little patches of it. And then on the surface of the skin as well, there are these peculiar blue discs, which are part of a fungal infestation that happened after she died, part of the burial environment that she was in. And she's lost her tail. That's about the only bit of her that isn't there. It's thought that Liuba died in a bog where she was first pickled by natural chemicals and then quickly frozen. Large specimens, like fully grown mammoths, usually deteriorate before this occurs. In fact, any type of frozen carcass is incredibly rare. Liuba's one of a mere handful of frozen specimens ever discovered. Isn't it peculiar to think that humans saw these alive? I think that's quite a strange thought, to know that there were people living here in Siberia during the peak of the last ice age, and these animals would have been in their environment. They would have been very familiar to them, just as people living in Africa and southern Asia share their landscape with elephants. Our relationship with mammoths dates back to the early days of modern humans in Europe. Their herds clearly inspired cave art. We've been transfixed by their majesty for thousands of years. But once extinct, mammoths became the source of myth and legend. Their huge bones were thought by some to belong to a long-lost race of giants. Others believed they belonged to a bizarre subterranean mole-like creature that died when it came to the surface. The name mammoth comes from an ancient Russian word mamont, meaning earthhorn, used to describe the animal's tusks. But it wasn't until 1728 that British scientist Sir Hans Sloane spotted the similarities between Siberian remains and a group of modern specimens that it was eventually realised that mammoths were a type of elephant. Major differences were obvious in the mammoth remains. Huge tusks, increased musculature to carry the tusks, a shoulder hump. The big question was how and why such an animal came to live in the extremes of the Northern Hemisphere. We now know that mammoths were a species created by and perfectly adapted to the most extraordinary period in Earth's history, the Pleistocene, or Great Ice Age. This 2.5 million year cold snap changed the planet and transformed the mammoth into a titan capable of thriving in the extremes of the Arctic Circle. That change occurred in a blink of evolutionary time and was driven by a perfect storm of exceptional events on a planetary scale.
For millions of years, Antarctica had been drifting southwards to its current position, sending the southern hemisphere into a deep freeze. And South America was charging northwards. It crashed into North America, and this altered the ocean currents and gave birth to the Gulf Stream. And the knock-on effect of that was increased precipitation in the northern hemisphere, which in lower latitudes fell as rain, and in the north as snow. While these tectonic events were changing the face of the Earth and propelling it into an ice age, there were also changes occurring on a celestial scale, producing dramatic fluctuations in the Earth's climate.
The Earth's distance from the Sun changes over time. Every 100,000 years, the Earth is at its furthest position from the Sun's warmth, and our planet enters a cold phase.
Then there's also variation in the tilt of the Earth on its axis, and that happens over a cycle lasting 41,000 years and affects the degree of difference in the seasons. Finally, the Earth also wobbles on its axis on a cycle lasting about 23,000 years.
When all those planetary factors coincide, winter takes over, with ice sheets covering 40% of the northern hemisphere. To glimpse the extreme conditions that mammoths faced, I'm visiting a remnant of one of those immense ice sheets.
This wall of ice marks a point 2/3 of the way up the Athabasca Glacier, which is about 4 miles in length and feeds off the huge Columbia ice field in Western Canada. But even that would have been dwarfed by the huge ice sheets of the Pleistocene. In places, the ice would reach up to 13,000 feet thick.
These glaciers are really beautiful, really craggy. You look down into the crevasses and they're deep blue inside. They're rivers of ice. It's incredible to think that most of that would have been under ice, with just perhaps the peaks of the highest mountains popping out above the ice sheets. This is amazing! Wow! Oh!
The ice sheets locked in so much water that they created cloudless blue skies. At latitudes below the ice, this provided perfect growing conditions for shrubs and grasses, creating a vast grassland known as the Mammoth Steppe. The steppe proved to be a massive untapped food supply for any animal able to adapt to eating its plants. This newly available niche drove the mammoths to evolve from their origins in the warmth of the southern hemisphere. At London's Natural History Museum, Professor Adrian Lister has traced those origins through his collection of bones, tusks, and in particular teeth.
What we've got here is a lower jaw or mandible of a very early mammoth. So here's the jawbone, and this is a kind of molar tooth that is adapted for eating plant matter, as all elephants and mammoths do. And by counting the number of enamel ridges in this tooth, this one's got about 10, we get an idea of what kind of plant food these animals ate. This one would suggest that this creature was eating the leaves of trees and shrubs, quite soft vegetation.
Teeth like this show that mammoths shared a common ancestor with living elephants about 6 million years ago. Over the next 3 million years, mammoths separated into different species as they moved north from their southern African origins. It was the early mammoths that grew truly huge, some standing over 4 meters tall at the shoulder and weighing twice as much as an African bull elephant.
From about 3 million years ago, we pick up the first remains of the mammoth line out of Africa, north of Africa.
As they moved through the Middle East and into Eurasia, mammoths evolved very quickly. Adapting to the cooling conditions, their tails and ears shrank to conserve heat. Woolly mammoths eventually ended up the same size as Asian elephants. Just like elephants, they probably spent most of their day eating, but the plants of the steppe were far tougher than those available in the tropics. Mammoths had 4 molar teeth, To cope with the wear and tear caused by their new diet, these molars evolved to have more ridges and higher crowns than seen in their relatives.
And so we have fossils like this molar from Siberia, and that is just about as far as it got. That's the limit. So you can see that there's about 26 of these enamel ridges. They're very closely packed. This is an almost 100% grass eater, which is a late Pleistocene woolly mammoth. This is from the last ice age.
As members of the elephant family, it's believed that mammoths would have behaved in a very similar way to their modern relatives. They would have lived in extended social groups, females of all ages, young males and infants. Now remains from the Siberian permafrost are revealing far more than just teeth and bones ever could. The frozen baby, Lyuba, shows that mammoths possessed an unusual tool, perfect for feeding on the steppe. She's got this very particular shape to the end of her trunk, which is quite different from modern-day elephants. And it's designed to be able to delicately pull up little tufts of newly sprouted grass and shrubs. Because Lyuba is so well preserved, new scientific techniques have enabled us to examine her internal organs, revealing startling adaptations to the extremes of the Ice Age. Recent CT scans show her kidneys are far larger than you'd expect in an animal of her size. This type of oversized kidney is also seen in desert-adapted camels, suggesting that mammoth's internal structure was also changing to cope with the dry conditions of the mammoth steppe, where there was plenty of food but little water. Frozen carcasses like Lyuba are revered by scientists as windows into the past. She was found on the banks of the Urabai River on Siberia's Yamal Peninsula. She was brought in from the cold by the French explorer Bernard Bouygues. He's hunted mammoth remains for over 20 years, amassing a huge collection, which he shares with scientists around the world.
Here we have approximately 450 remains of different mammoths, yeah? But of course not 450 full carcass. But each bone can tell you the story of the animal. So we can say that here we store around 450 mammoths.
Bernard works closely with a large network of indigenous Arctic people. They contact him when they stumble upon mammoth remains. He now gets more calls than ever as the permafrost is melting at an unprecedented rate, exposing potential new finds. A brief window of fine weather bathes the Arctic in round-the-clock sunlight each summer. It's the perfect time for me to join him as he makes camp and starts a new expedition following reports of a mammoth discovery. If true, it will further our understanding of these Ice Age titans.
We're deep in the tundra here, about 200 miles north of any major town, and it's beautiful sunny weather at the moment, but it could turn at any point and the snow could return. This is such a dynamic time. Things are on the move and things are being eroded as well. The riverbanks are literally falling into the rivers as the water levels rise, and so it's precisely now that ancient remains start to come to light.
Bernard's a member of the International Mammoth Committee, a team which includes paleontologists, geophysicists with ground-penetrating radar, and even an ex-KGB officer. Professor Dan Fisher of Michigan University is the world's leading mammoth tusk expert. He visits the Arctic each year, and through analysing hundreds of tusks, he's developed an unrivaled understanding of the mammoth populations that once roamed here.
So did tusks grow throughout the life of a mammoth? Do they actually represent a record of an entire lifetime?
They do. That's one of the, I mean, just thinking of it sort of aesthetically, it's almost magical, but here these things are that do grow throughout life, that are virtual diaries. There are days represented, each day as a thin layer of dentin. Days, weeks, years are all recorded structurally and in patterns of compositional variation. And of course they didn't do it for our benefit, but what insights it gives us into the lives of these animals.
Although each tusk is a valuable source of information, it's only when multiple finds are compared with each other that Dan's able to construct an understanding of entire mammoth populations.
I think it can seem as though you are stamp collecting, that you're just collecting specimens for the sake of it. But there's a real scientific value to them.
There is. The problem is not solved. We've established that the data that we would need are available. We've established the first few points that suggest a direction and give some meaning to the patterns that we see.
Understanding mammoths takes more than museum work and textbooks. It requires teams like the International Mammoth Committee to venture into the wilderness, working with locals and hunting for specimens, at times chasing nothing more than rumours.
Bernard's just been on a reconnaissance mission, so hopefully he should be able to corroborate whether there is in fact a mammoth around here or whether it's all wild tales. Welcome back, welcome back. So, Bernard, how did it go?
Difficult to say, you know, how fast the things are changing, yeah?
Yeah.
So some days ago it was under ice. And today and tomorrow, I don't know. We'll see what will happen.
Have you been able to speak to anybody that's actually seen it?
No, because it's a little bit secret, yeah? You know, right. the one who knows about the mammoths don't tell to anybody, and we'll speak about blah, blah, blah. But I see that you are very impatient, and
I'm excited to get there and have a look.
I'm also.
Bernard has scant information to work with. During this hunt, his team are hitchhiking with the Siberian Gas Company's private train network to visit the scene of a mammoth sighting. It's now flooded after the spring snowmelt.
The location is quite big, yeah?
It is a large lake. And do you think the mammoth is where in relation to the lake then? Because it's a big lake.
It's difficult to know. It can be in the middle of a lake, it can be on this side.
I hope it's not in the middle of the lake.
Yeah, it can be.
The team is trying to use ground-penetrating radar to search for specimens underground. Here they work for days in an effort to find one of the rarest of all prehistoric riches, a frozen carcass. Looking for ancient mammoth remains is unpredictable. It's a science, but an inexact science. This hunt concludes with a negative result.
I am a little bit frustrated, but just now I need to keep in mind how to organize the next step for this mammoth, because I will not let him, let's say, alone, yeah? We need to take care of him, see what will happen during the summer. Yeah? Ej, Kirill, plachoj muzik, nie organizować do końca naszych ekspedycji.
Each new specimen has the potential to deepen our understanding of mammoths. In many ways, we actually know more about mammoths than we do about many living species, enabling us to recreate how they would have lived on the Siberian plains. Much of that understanding has come from the recent advances in analysing mammoth tusks.
I first met Dan Fisher out in the field in Siberia, but now I've come to his place of work at the University of Michigan's Museum of Natural History to find out what happens to the tusks which he brings back with him.
It's the internal structure of the tusk which reveals a mammoth's true secrets. But the only way to see it is to break a tusk open.
Dan, this is a beautiful tusk. It seems like an almost sacrilegious thing to think of doing. You know, this has survived for thousands of years and we're going to cut it open.
I understand that, but what if you found an incredible old manuscript and it was closed? Would it be sacrilegious to open it and read it?
Yeah.
Would it be sacrilegious to learn from it? Yes, in some sense we are, you could say, violating the tusk, but in another sense, it's really capturing the story it has to tell.
Which tooth is it that forms the tusk?
The tusks of elephants and their relatives are modified second incisors, so not our middle ones, but just lateral to that.
The lateral incisors?
Right.
And can you tell if it's a left or a right?
Yes, this is a right tusk based on the geometry of curvature is such that it's characteristic of what we see on the right side of mammoths' faces.
Yeah. So a right tusk. And do you know how old this animal might have been at the time of death?
This was probably about, say, a 15-year-old. That's a ballpark guess right now. We'll find out after we cut the tusk.
Yeah, so teenage mammoth.
Right.
Dan needs a clean cut, so he builds a bespoke cradle for each tusk before slicing it open.
All right.
The largest mammoth tusks ever found weighed almost 120 kilograms each, far more than an average adult man. Both male and female mammoths possess large tusks, and it seems that the weight of carrying such huge objects required them to have larger neck and shoulder muscles than we see in modern elephants. The surface of tusks show microscopic scratches, possibly caused when mammoths used them to clear ice and snow while foraging for food. And polished areas indicate they may have favoured one of their tusks for resting their trunks on.
Well, we've done it. Now we've just got to open it up. Oh.
The moment we've waited for.
Can I do this then?
Yes, you certainly may. So just lift up in a way.
Look at that. That's beautiful.
It's gorgeous.
So I can see a darker streak and a paler one and a darker one. So is that a year in this animal's life?
That would be a year's, yes. The dark portions basically are winter. And so the light and dark together would make 1 year, and the next light and dark together the next year.
So this is a record of an ancient winter.
Right.
The tusk is packed with information, but the patterns in it are hard to see until it's polished and viewed under ultraviolet light.
Oh, wow.
Okay, now that is a lot better.
That's fantastic.
That's what I
What a
like to
difference.
see.
That's
isn't
amazing.
it?
That's so much more
It's
detail
like
than we
you've
could
put on
see in...
magic glasses and you can see
Yeah,
the tusk.
yeah.
Like other teeth, tusks grow from the jaw outwards. Once highlighted, the growth bands are clearly visible, spreading from root to tip. Although this tusk shows about 15 years of growth, there are in fact hundreds of microscopic growth lines present.
We're seeing some really beautiful fine lines here.
Yes.
So we can see successive winters and summers,
Yes.
winters and summers,
Right.
winters.
Now, in fact, the direction of time, though, is outside in. So the years, it's opposite of trees, is the way to think of it. In a tree, you would think time goes this way. But in a
Yeah,
tusk,
yeah.
time goes this way.
And it is like looking at tree rings. You know,
It
we have
is.
these kind
Oh,
of
yeah.
annual cycles in tree
Yeah.
rings as well.
Except that tusks have weeks and days, which trees don't have.
That's fantastic.
This is just incredible and very, very beautiful as well. Under this ultraviolet light, we can see this detail within the tusk that is a thing of great beauty, but underneath that beauty, inside that beauty, is this information about this mammoth's life. Drilling out tiny amounts of ivory from daily growth lines allows Dan's team to analyse chemical isotopes laid down on that day, painting a prehistoric picture of the animal's life with a level of detail that's not possible for any other extinct species. Oxygen isotopes from the water it drank reveal where the mammoth roamed throughout its life. Nitrogen isotopes reveal where a mammoth was getting its protein from. We can even pinpoint exactly when an infant was weaned from its mother's milk. Carbon isotopes show the types and relative quantities of plants eaten. Thinner and darker growth lines indicate winters when less food was available, and in some cases, periods of starvation. Because the growth lines are so detailed, Dan can identify the point when, upon reaching sexual maturity, teenage male mammoths were cast out from their herds and left to find food for themselves. It's also possible to see that sexually mature males starved themselves every year during the period known as must, just as living elephants do. This sees them all consumed by the desire to find a mate. They fail to eat, and their tusks show a period of decreased growth. The tusks also bear witness to traumatic events, including the most spectacular of all sights, a battle between males competing for mating rights. The study of mammoths is nothing new. They were first described scientifically over 200 years ago, but now new techniques in DNA analysis are being used to decipher the mammoth genome. Here at America's Penn State University, geneticist Stefan Schuster runs a team of DNA specialists who are using cutting-edge 21st century technology to analyse mammoth DNA. Their results are pushing our understanding of mammoths far beyond what was previously possible.
How difficult is it to extract DNA from a mammoth?
It's quite difficult because there's only tiny amounts of DNA left. At the same time, you need to imagine that all the bacteria that lived on that animal deposit their own DNA on top of the DNA coming from the animal.
DNA contains the genetic instructions used in the development and functioning of all animals, but it deteriorates very quickly after death. In the case of long-dead mammoths, many of the remains recovered provide virtually no usable DNA, so Schuster uses the plentiful supply of mammoth hair as a source.
So take me through the process of extracting DNA from a mammoth.
It's actually quite surprising. It's not so unlike what you would do with your own hair. So first we wash it, we rinse it with water, we shampoo it, and in the end we even bleach it.
Yeah.
And then we use an enzyme to digest the hair shaft, and we release the mammoth DNA that's stored on the inside.
Genetics labs commonly use bone as a source of ancient DNA. But frequently contaminated, mammoth bones often provide little usable DNA. Schuster's use of mammoth hair provides a surprisingly pure sample.
In one instance, we were working on an individual that was 18,000 years old, and we could get more than 90% of mammoth DNA from it. And the oldest specimen that we sequenced was roughly 60,000 years old, and there we still get more than 50% that is endogenous mammoth DNA.
Genetic analysis has dispelled a myth about the very source from whence this DNA comes: mammoth hair. Mammoths have traditionally been depicted as having orange-brown hair. It's now known that they possessed similar genes to humans for hair coloration. Theoretically, they could have been blonde, ginger, or brunette. Whatever the colour, the quality of the coat was crucial. Like the Arctic muskox, mammoths sported double-layered coats. Short, dense, downy hairs next to the skin provided insulation. Long, shaggy guard hairs kept out the wind, rain and snow. Thick hair is an obvious cold weather adaptation. But now advances in genetic studies provide us with detailed insights into molecular level adaptations, allowing mammoths to cope with the extremes of the Ice Age. Dr. Kevin Campbell of Manitoba University in Canada investigates how their blood evolved to cope with the freezing conditions.
What I'm really interested in is the protein hemoglobin, the primary component of the blood. This protein is really the interface between the atmosphere and the cell. You know, it's that transporter protein of all the oxygen in the body.
Kevin usually studies mice and how the hemoglobin in their blood delivers oxygen to their cells, especially in cold weather. But his childhood obsession with mammoths prompted him to try to see if he could figure out how well the hemoglobin in mammoth blood worked in the extreme cold of the Ice Age. However, blood dries up and decomposes quickly, so no mammoth hemoglobin has survived in any of the specimens discovered so far. But because Kevin had the mammoth instruction manual in the form of their decoded DNA, he was able to compare their code for making hemoglobin with that of their close relatives, modern elephants. There were only 4 differences between the codes. This enabled Kevin to use host bacteria to produce his very own protein based on modified elephant DNA.
And effectively, we turned it into mammoth DNA, functional mammoth DNA.
A functional protein that has been extinct for thousands of years.
For thousands of years.
A functional protein that hasn't existed in any animal for thousands of years. That's amazing. It's starting to sound a little bit like Jurassic Park.
And it's not even just functional, it's authentic. This is, in essence, virtual time travel. The end product is precisely the same. Had I gone back in time and taken a blood sample, it is absolutely authentic.
That's absolutely remarkable. And once you've got the mammoth hemoglobin, then you can test it. You can see how it does. You can look at how it picks up oxygen and how it lets go of it.
Precisely the same way as I would take it from your blood.
In most animals, hemoglobin's ability to deliver oxygen to body tissues decreases at low temperatures. To see if mammoth blood had any special adaptations to the cold, Kevin tested the hemoglobin he'd created across a range of temperatures.
And sure enough, when we looked at the hemoglobin of the mammoth versus that of the living animals, at normal body temperature, around 37 degrees Celsius, their properties were the same. It had the same ability to pick up oxygen and offload oxygen.
But what about at low temperatures then?
Yeah, so as temperatures went down, the abilities diverged. So as temperature got lower and lower, mammoth hemoglobin, we found, was more able to offload oxygen than that of the Asian elephant, and far better than that of humans.
It is incredible to be able to take ancient DNA and to resurrect a protein from the past, a protein which hasn't existed in a living animal for thousands of years. And once we have this protein, we can look at how it behaves. Mammoth hemoglobin can deliver oxygen at very low temperatures, meaning that mammoths could let their legs, their extremities, get cold. And they could then hold on to their body heat and conserve energy through the long, cold winters of the Ice Age. It was crucial to survival.
These new molecular level investigations are bringing the science fiction style possibility of cloning a mammoth ever closer. In the far east of Siberia, an incredible new discovery is being heralded as the holy grail of mammoth science. In the city of Yakutsk, members of the International Mammoth Committee have unearthed a completely intact frozen mammoth thigh bone. Although thousands of years old, it's one of the best preserved bone specimens retrieved from the permafrost. So perfectly frozen that it contains pure mammoth bone marrow. This could be the best source ever of fully intact mammoth cells with undamaged DNA. The marrow will be sent to a lab in Japan where they will try to extract intact cell nuclei and insert them into a host elephant egg. If successful, scientists there predict that they will be able to clone a mammoth by using a female elephant as a surrogate mother within 5 years. But the ethics of creating such a clone is likely to kick up a storm of debate. Should scientists even be attempting to resurrect an extinct species? Rather than trying to clone a long-dead species, many scientists are far more eager to understand why the mammoths died out in the first place. Their extinction coincided with the warming climate at the end of the Ice Age. The environment they'd perfectly adapted to was changing. The blue skies that created the steppe grew heavy with cloud. Rain returned to the north. Dry grassland was replaced with wet tundra plants and forests. The mammoth's favoured food supply was dwindling. But the genetic studies completed recently suggest that woolly mammoths had coped well with similar changes in the past. A population crash occurred 30,000 years before they finally disappeared. But they recovered, suggesting that something else other than changing habitat may have spelt the end.
The mammoths had survived through many fluctuations in the climate, through all of these warming and cooling cycles. Why was it at the very end of the Ice Age that they seemed to give up?
It might not have been an all or nothing process that is just depending on this one last cycle. It might actually have been a gradual process that after every warming and cooling period, that not only the population numbers but also the diversity of the animals went down.
Professor Dan Fisher thinks he might now have the answer. After analysing hundreds of ancient tusks from different mammoth species, he's uncovered a pattern suggesting that mammoths were being increasingly hunted by predators as the climate grew warmer and their numbers dwindled.
So you've obviously seen changes in
Yes.
lots of tusks that you think are evidence of predation pressure. So what are those changes? What was going on in these mammoth populations?
The changes that we see that seem best explained by increases in predation pressure are things like maturation at a younger age, calving intervals, or intervals between calves and females that are, if anything, shorter. In other words, these are changes that are reasonable responses to a changing balance of risks between survival and reproduction. It's better if there's more predation going on to reproduce a little bit earlier, even if it's smaller body size, and to have a few more calves, even if there's less investment in individual calves. It's a better bet, so to speak, in the long run to have that kind of a life history in a regime of higher incidence of predation. So I think the evidence is that human hunting was an extremely important aspect of what drove the extinction.
If Dan Fisher is right, it's a huge step forward in explaining mammoths' extinction. He's sure mammoths were maturing fast and having babies early towards the end of the Ice Age, a classic sign that they were being hunted. But in Siberia, the evidence that predation was by man is scarce. Now potential new evidence has surfaced. Dan's colleague, mammoth hunter Bernard Bouygues, thinks he might have made a new discovery which could support the idea that humans hunted mammoths to extinction. In a secret location on the very edges of the Arctic Ocean, thousands of miles away from where I first met him, he's recovered a new specimen, which was found frozen in the banks of a river. He's suggesting it shows signs of human interaction. This could be a missing link in the human-mammoth puzzle. I seized the chance to witness such a find and fly back to Siberia to meet Bernard, who's transporting the mammoth across the frozen tundra. We agree to rendezvous in the remote wilderness of Yakutia.
Well, this is it. This is the rendezvous point. And I know they're on their way. I can't hear anything yet, though. But it is incredibly cold. I hope it's worth it. They're bringing this mammoth in. They're going to eventually take it to Yakutsk and we'll be able to have a look at it there. And hopefully it will be another piece of the puzzle. It will add to our understanding of these ancient creatures that once roamed around this landscape. Oh, I think I can see them. You see the lights over there on the horizon? They've just crested the hill. Oh, this is fantastic. It's just so exciting. Bernard! Oh my God! You've done it!
Yeah.
Oh my goodness. And where's the mammoth?
The mammoth is lying like this, yeah? He's on the back.
Yeah.
And the four legs up. And it's a young mammoth.
Yeah, it's smaller than I expected.
Yeah. It's a wonderful specimen, you will see. I want to show you.
Oh, fantastic.
I want to show.
Oh, that's brilliant.
I want to share with you.
All right, lovely.
We board an ex-military transporter plane to travel a further 500 miles south, where we'll start the analysis of the mammoth in a permafrost ice cave. Will this frozen carcass reveal any clues to help explain the mammoth's extinction?
I can't wait to see it. It's travelled all this distance. It is like unwrapping an ancient mummy.
Yeah.
It is an ancient mummy.
It's an ancient mummy, sure. The trunk.
It's the trunk.
Yeah. Beautiful.
Oh my goodness.
It's
Oh my
it's
goodness.
just-
That's amazing.
Yeah, this round hair, yeah?
That fur's really long.
From its size, it looks as though this mammoth was about 3 or 4 years old when it died. After thousands of years lying frozen in the ground, it's twisted and contorted. Now lying on its back, its head is flopped to one side and its legs stick up in the air. Its foot pads and thick strawberry blonde hair are exquisitely preserved.
I'm jealous, he has much more hair than me.
Isn't it hard to believe that this is something which died so long ago?
Yeah,
I mean,
no,
it doesn't look like an animal which has been dead for thousands and thousands of years, an animal from the Ice Age.
Yeah, cannot believe that it's more than 10,000 years old.
It looks so fresh.
So
it looks
fresh,
almost
yeah,
alive.
Yeah,
It's-
yeah.
You look beautiful.
It is beautiful.
This specimen is also mysterious. We don't yet know if it's male or female, or when it died. But most mysterious of all are the signs of human interaction. It has 2 large cuts on its back, through which many of its bones have been removed, including its spine and skull.
So this is very clearly not natural processes. This is absolutely human tampering. The really big question is, did this happen recently or did it happen in antiquity?
For me, definitely it happened a long time ago. A long time ago, because recently, can you see, the skin is dry, yeah, mummified,
I cannot see how it can be cut. Then it's not so easy to open it, and of course we need to work more on this. Yeah, but
yeah, and this is a wonderful, wonderful thing. You know, it's an amazing specimen of a young mammoth, and this is just the beginning, isn't it? Because now the investigation will proceed, and we will find out as much as we possibly can about the life and the death of this animal and the way that humans interacted with it.
Yeah, this is exciting. This is very, very exciting. Yeah.
It's actually very difficult to see anything with the mammoth in this frozen state. The scientists are going to have to defrost it to get to the bottom of this story. How exciting, though, if they do find out that this mammoth was tampered with by ancient people.
If it was interfered with in the deep past, this would be an incredibly important specimen, showing interaction between ancient humans and woolly mammoths. People usually kill animals for food, but this specimen hasn't been butchered, and although now dried out, most of the meat is untouched. Humans have certainly interfered with this carcass. Bones have been removed, and the tusks are missing. But for me, the big question is whether that happened very recently or in the deep past. The scientific investigation is only just beginning. It may be years before we have the answer.
It is so exciting and such a privilege to be here with this mammoth as it's unwrapped, and to have been with it on its journey as it comes in from the tundra. It's a historic moment for Yakutia, for Siberia, and for anybody that's interested in mammoths.
Iconic and majestic, mammoths were once a mystery. Now we understand them better, we still revere them. Perfectly adapted on the inside and out, they withstood the extremes of the Arctic Ice Age, while few other animals could. Genetic and chemical analyses are revealing the secrets of their lifestyles. Long gone from our landscape, we're taking a step closer to bringing back these incredible beasts, using the latest techniques in cloning. And this brand new discovery may well take us a step closer to understanding how our own ancestors could have contributed to the extinction of the greatest of all Ice Age titans, the woolly mammoth.
Exploring the lost land of the volcano this weekend on BBC HD with an encounter with the world's smallest parrot. That's at 4:30 tomorrow.